Hello everyone, this is Philipp Jonas for Kalamazoo Valley Community College, and in today's lecture we're going to discuss consumers, producers, and the efficiency of markets. So up until now we have looked at supply and demand and its impact on markets in terms of prices and quantities. But there's another very useful tool in our toolbox of analysis. Consumer and producer surplus allow us to evaluate how market outcomes affect the buyers and sellers in a market. Let's start by talking about the buyers. The idea of consumer surplus is based on the notion of willingness to pay. Willingness to pay refers to the maximum amount a buyer is willing to pay for a product. So let's say you go to the store and you want to buy yourself a loaf of bread. There's a price that you'd be willing to pay, but there's a higher price that you'd not be willing to pay. Somewhere in between those two exists the very highest amount that bread could cost, and still you'd be willing to buy it. That's your willingness to pay. So for the sake of argument, let's say we've got 4 perfectly randomly chosen names and their willingness to pay for an iPad. Let's start with a simple question. Let's say this iPad is actually available at a price of $200. Who among our buyers would say, yes, I want to buy an iPad? Well, looking at the willingness to pay, we have Anthony and Flea whose willingness to pay exceeds the price. They buy. Chad and John will not. Now, for the sake of simplicity, we're going to go ahead and restrict each of our potential buyers to buy 1 iPad maximum, so that we don't have to worry about what's the second one worth to them compared to the first one. So really what we've just established is a point on the demand curve. If price is $200, quantity demanded is 2. Let's go ahead and take this approach to fill in an entire demand schedule for our band members. Notice the demand schedule looks a little bit different than we've done so far. Instead of having just a set of individual prices in the table here, I've identified entire price ranges and the associated quantity demanded. That's going to make it a little bit easier to talk about how the consumer surplus can be thought of on a graph versus a schedule. We'll get to that later. So for now, if the price of the iPad is above $300, nobody wants to buy the iPad. That means quantity demanded is 0. Starting at $300, we've got Flea jump in, all the way down to $251. He's the only buyer, so quantity demanded is 1. And now at $250, it goes to 2. So Anthony starts buying, but of course, Flea is still among the buyers. Lower price is good for him, of course. So now we have 2 buyers. At $175, we got 3. And then again, we're restricting all of them to buy 1 maximum. So even if the price falls to 0, we have 4 quantity demanded as our maximum. So what we've just done is we've derived a demand schedule based on this table of willingness to pay in yellow on the left. That means we can go the other way around as well. Imagine I'd only given you the information in the white table and asked you, what is the willingness to pay of each of these buyers? So looking at that table, let's start with Flea. That one's easiest to see. What's the highest price where Flea still buys? $300. Then he's out. So 300 is his willingness to pay. Let's go 1 row lower. Talk about this one right here. So the highest price in this row is $250. And that's the willingness to pay for Anthony. It's not the willingness to pay for Flea, because Flea is willing to pay even more, up to the $300 mark. In other words, the highest price in each of these rows represents the willingness to pay for that buyer. We'll go back to that notion as soon as we've drawn this information up as a demand curve. So let's collapse that demand schedule a little bit to the right and go ahead and draw in the information on the demand schedule, which is going to look a little different than we've done so far. Since we don't have just a couple of individual points, we have entire ranges of prices, we can fill this demand curve in segment by segment. anywhere above the $300 price. Since we have entire ranges of prices, we can fill in this demand curve segment by segment. Anywhere above $300, nobody is buying an iPad. Then at the $300 mark, we go from 0 exactly to 1 buyer. And we stay at exactly 1 buyer all the way down to $251. At $250, we get the next step. The second buyer jumps in. And again, we are at exactly 2 buyers down to $176. If you know every point on a demand curve, it's no longer a straight line. It's a little bit like zooming in on a demand curve that is a straight line and seeing each individual step as each purchased unit jumps in. This is how we can draw a demand curve from a demand schedule that incorporates every possible point. Now remember, based on the information in the demand schedule, we were able to determine the willingness to pay of each of our buyers. We've now drawn that demand schedule as a demand curve. That means if I take away the demand schedule, we can figure out willingness to pay based on the information in the demand curve. And to do that, let me introduce a new term to you, the term marginal. Marginal thinking is a very important type of thinking in economics. It refers to thinking about a process step by step. Here's our first application of this type of thinking. A marginal buyer. A marginal buyer is the most recent buyer who has started buying a product if you're thinking about falling prices, or if you're thinking about rising prices, it's the first buyer that would stop buying the product. It's the buyer on the edge, so to speak. That's what thinking at the margin refers to. For example, at a price of $200, we have 2 buyers, Anthony and Flea. But we'd only refer to one of them as the marginal buyer. At the $200 mark, that would be Anthony, because when the price rises, he'd be the first one to stop buying. So let's go ahead and think about how to identify the willingness to pay of each buyer. Again, at $200, we have 2 buyers. Anthony is the marginal one. He pays as much as $250 before he leaves. That makes $250 his willingness to pay, and going a little bit earlier, makes $300 Flea's willingness to pay. In other words, in order to identify the willingness to pay of each buyer on a demand curve, you look at the highest point of the demand curve where that buyer is at the margin. So for example, at $275, Flea is the marginal buyer. To find his willingness to pay, go to the highest point on the demand curve. That would be $300. At $200, Anthony is the marginal buyer, but $200 is not his willingness to pay. His willingness to pay refers to the highest amount he'd be willing to pay. Going down the demand curve, this allows us to identify all 4 willingness to pay. So this is the concept of willingness to pay. The most a consumer is willing to pay for a product. Based on it, we are going to construct our concept of consumer welfare, which is called consumer surplus. The difference between what a consumer is willing to pay versus what they actually pay is consumer surplus. Or, expressed in algebraic form, it's willingness to pay minus price. Let's go back to our iPad example. So let's say this iPad is available at a price of $260. At that price, we have 1 buyer, Flea. Flea is willing to pay $300. That's what the iPad is worth to him. But he actually pays $260. The difference between those numbers, between what it's worth to him versus what he actually has to pay. That's how much better off he is as a consequence of having bought the iPad. That's what we call consumer surplus. So what about our other band members? Should we indicate that they have negative consumer surplus because the iPad is more expensive than what it's worth to them? Not at all, because they are not buying the iPad, so they are unaffected. In higher level economics courses, you can learn about the concept of what if we mandate a consumer to buy a product? Then it is possible for them to have negative consumer surplus. In our example, it starts and ends with flea and a consumer surplus of $40. This is the arithmetic. But most of the time we're going to look at this in terms of a demand curve and some simple geometry. So let me show you the same notion going back to the demand curve. Here is our demand curve from earlier. And for our first example, we're going to stick with the iPad having a price of $260. Again, consumer surplus will be the difference between that and flea's willingness to pay, which is $300. But there's a geometric interpretation as well. Look at the area I just highlighted in green here. This rectangle has a width of 1 unit and a height of $40. Its area is equal to the consumer surplus. Let's get back to that notion with our next example. Let's say the price of the iPad is lower, $220. Now we're going to have to compute consumer surplus for two buyers. First we have flea, willing to pay $300, actually paying $220. Again, notice this rectangle, it's equal to $80 in size. In addition to that, Anthony is now a buyer as well. His willingness to pay is $250. That means his consumer surplus, 250 minus 220, is $30. Notice the rectangle. Now this leads us to an important concept in economics. Even though Anthony and Flea are buying the same item for the same price, we don't say that they have benefited the same. Flea is benefiting more than Anthony because he values the item more. Consumer surplus can be different for different consumers, even if they're buying the same thing at the same price. Now let's add their consumer surpluses together to get total consumer surplus. $110 or the area highlighted in green. Let me introduce you to the general rule of how you find consumer surplus using a demand curve. It's the area below the demand curve above the price, below the demand curve, above the price, for however many units are being sold. So in this example, a total of 2 iPads are being sold. We look below the demand curve and above the price for those 2 iPads. If, on the other hand, only 1 iPad was available and it went to Flea, we would look below the demand curve and above the price, only out to the number 1. So that can happen if there's a limited number of the products and not everybody who wants to buy is able to buy. Now, this is a nice way of showing how a demand curve and a demand schedule can both be used to calculate consumer surplus. But think of our demand curves this semester. Normally we don't have every single point of them available. Normally they don't look like they've got these steps in them. Instead, most of the time we're looking at demand curves that are nice straight lines. So how do we work out consumer surplus now? We can't do it off the demand schedule since we don't have all the numbers. Instead, we go directly to the geometric method. Consumer surplus is the area below the demand curve above the price. Assuming for a second that this demand curve for shoes has 15 buyers buying shoes at a price of $30. There's no limit on how many shoes they can buy, so we don't have to worry about stopping before we hit the demand curve. You'll recognize that the resulting shape is a triangle. As you know, the area of a triangle is computed as base times height divided by 2. Those are the two types of areas we're going to be working with. Rectangles, base times height. We've already done that a few times. And now for the first time, triangles. Base times height times 1/2. And let me draw extra attention to one of these dimensions. The height of this triangle is $30, going from the price up to the top of the demand curve. Sometimes students will indicate that the height of this triangle is $60 because there's a 60 up here. They're very used to graphs that start at 0. Notice this triangle doesn't start at 0, it starts at 30. So let's do the math. This triangle is $30 high, $15 wide, and then after multiplying those two numbers, we divide by 2. The result is $225 worth of consumer surplus. Let's do that one more time. Let's go ahead and change the price of the product. Let's say shoes are selling for $40 instead. That's going to impact consumer surplus. Buyers are worse off when prices are higher. Specifically, looking below the demand curve and above the new price, we find a triangle that's only $100 in size. Now, do you remember the example we did for business revenue back in our chapter on elasticity? Same as there, we can look at the area of consumer surplus that was lost and interpret this change. There are two things going on. First, when the price rises, some consumers stop buying the shoes. Quantity goes from 15 to 10. So whatever consumer surplus those 5 shoes used to generate, that goes to 0. Let's look at the size of that triangle. It's $10 high, $5 wide, 5 times 10 divided by 2. That's $25 worth of consumer surplus lost. Secondly, 10 pairs of shoes are still sold, but they each sell for $10 more. That means consumers are paying $10 more each for 10 additional shoes. That's $100 additional dollars they are paying. The size of the rectangle shaded in green, $100. That's the second source of loss. So everything fits together very nicely. Before the price was at $40, back at the $30 mark, consumer surplus was $225. That's the size of this entire triangle, all 3 types of shading. When price rises, consumers lose $25 in yellow shaded triangle, $100 in green shaded rectangle, which makes their new consumer surplus $100. And that's consumer surplus. Now let's talk about the same notion for sellers. How do we calculate their producer surplus? Where the consumer surplus is based on the notion of willingness to pay, producer surplus is based on the notion of cost. What does it cost a seller to sell the product? Now, economics uses a very specific notion of cost called opportunity cost. Everything you have to give up to sell a product, not just the things you're paying money for. We'll talk about this distinction in great detail in our chapter on the cost of production. For now, let me start with a simple example. Let's say we've got 3 perfectly randomly chosen individuals who are in the business of mowing lawns. For simplicity, again, we'll restrict each of them to mow 1 lawn at the most. Here's the rule for how they decide if they want to mow a lawn. They will mow a lawn if the price they are paid is equal to or greater than their opportunity cost, what they have to give up, to mow a lawn. So notice, price versus cost. Price is what a seller receives, cost is what they have to give up. For example, if the price for mowing lawns was $25 in this neighborhood, Jack and Janet would be willing to each mow a lawn. Their cost is less than this price. Chrissy would not be willing to mow a lawn. Let's go ahead and put together an entire supply schedule on this, since we now realize that the seller's cost is a measure of their willingness to sell. Same as on the demand side, for starters, I will have a supply schedule that has entire ranges of prices, every possible point on our supply curve. Anywhere below $10, nobody's willing to mow a lawn. Starting at $10, Jack is in. Starting at $20, Janet is also mowing. Jack, of course, is still mowing, so now we have two sellers. And starting at $35, Three's Company. Let's go ahead and take this supply schedule and represent it as a supply curve. Same as before, since we have every possible point on this supply curve, it'll have a distinctive stepped shape. That's because we have entire ranges where there's no change in the quantity supplied. Normally, we only have a few points of the supply curve and we connect them into a smooth line. Now, we were able to figure out the supply schedule on the right based on the cost of our sellers. Since the supply curve reflects the same information, that means just using the supply curve, we should also be in a position to determine the cost of our sellers. Let's go ahead and take that supply schedule away. How do we figure out each of their costs now? Well, remember, they start selling once the price is equal to or greater than their cost. So let's look at our first seller here, Jack. Below 10, he's not selling. He starts selling exactly at 10. That means 10 must be his cost. Same as on the demand side, I'll describe this using marginal language. The marginal seller is the seller who would first stop selling when the price falls. So for example, at a price of $15, we only have one seller. That makes Jack, by definition, the marginal seller. We then look at the lowest point of the supply curve to identify his cost. Let's go to a higher number, let's say at $25. We now have two sellers, but only one of them is the marginal seller, Janet. So now look at the lowest point on that supply curve, where Janet is still the marginal seller. That's her cost, $20. And finally, we can find Chrissy's cost using the same method. Now that we have learned about cost, let's go ahead and put together the notion of producer surplus. That's our measure of the well-being of sellers in a market. It's a very similar idea to consumer surplus, but from the producer's perspective, price is what they receive. It's their benefit. So to calculate producer surplus, you take the price that a seller receives minus their cost of selling. For example, let's say lawn mowing services are currently selling at a price of $25. Let's look at our sellers. There are two of them. Jack first. His price is $25, his cost $10. That makes his producer surplus $15. Notice the rectangle I've shaded in here. It too is $15 in area. Next we have Janet. Same $25 price, but her cost is higher. She has a cost of $20. That makes her producer surplus $5. And Chrissy, of course, is not selling, so we're not going to count her for any producer surplus. Notice, same as on the buyer side, even though we have the sellers selling the same service at the same price, that does not mean they profit the same, since different sellers can have different cost. In this example, total producer surplus is $20. the sum of Jack, Janet's, and Chrissy's individual producer surpluses. And you'll notice there's a geometric interpretation as well again. It's the area above the supply curve, below the price. And should there be a limit on how much can be sold above the supply curve, below the price, for however many units can be sold. So for example, if only one lawn can be mowed, you stop the area at 1 unit right here. In that case, only Jack would be able to mow a lawn. Now, this is producer surplus when we are looking at this distinctively stepped supply curve that results from having a supply schedule with every possible point on it. But that's not what we do most of the time. Most of the time, we have supply curves that look nice and smooth like that. So let's go ahead and identify producer surplus here. Above the supply curve, below the price. Once again, we find a triangle. And once again, take extra care to determine its height. Its height is the difference between the price and the lowest point of the supply curve, which in this example is $15. So the height of that triangle is $25. Its width is 25 shoes. 25 times 25 divided by 2, since it's a triangle. We would say that producer surplus is $312.50 in this example. Let's do another example. Let's say the price of the shoes falls to $30. Obviously, that's going to be bad news for our sellers. They'll now earn less producer surplus. And of course, we can look at exactly the mechanics of change here. So the new producer surplus is $112.50. They've lost $200 in producer surplus compared to the former bigger triangle. Let's see where those $200 went. First, when price falls, fewer units are sold. That's the law of supply in action. Specifically, sellers go in this example from being willing to sell 25 shoes to being willing to sell only 15. That's 10 fewer shoes. The triangle shaded in orange here represents the producer surplus those 10 pairs of shoes used to generate. $10 tall, 10 shoes wide, multiply and divide by 2, that's $50 worth of lost producer surplus. Secondly, the shoes that still are sold, there are 15 of them, those sell for $10 less each. So 15 shoes times $10 less each, that's $150 less our sellers are earning from those shoes. I've highlighted this in the shaded green area. Together, this explains the $200 loss to sellers. Some due to fewer shoes being sold, some due to lower producer surplus on shoes that are still sold. And that is producer surplus. Let's do a small recap and finish out by talking about what efficiency means. We've learned about 2 measures of well-being in a market. The first was consumer surplus, which measures the well-being of the buyers. It's the difference between the value of a product to buyers, what we call willingness to pay, and what the buyers actually pay for the product. The second concept was producer surplus. It's the difference between what the sellers receive for the product and their cost, which is a measure of their willingness to sell. It represents their benefit from participating in the market. In economics, if we want to measure how efficient a market is in its totality, we calculate its total surplus, which for now we'll think of as consumer surplus and producer surplus added together. Later, we will add another notion of efficiency to the market beyond consumer and producer surplus. but not for today. Now look at the calculation for consumer and producer surplus. If we add these two concepts together, we can simplify a little bit. Consumer surplus, value to buyers minus what the buyers pay. Producer surplus, what the sellers receive minus cost. If we add these two formulas together to calculate the total gains from trade in the market, we are left with buyer value minus seller cost. What happened to the price? Well, it was a negative number for our consumers added to a positive number for our producers. They cancel. That means if you are looking at the total gains from trade in the market, you can think of it as the difference between what it costs to produce versus what it's worth to the consumer. This is what we call efficiency in economics, and it's a concept central to the study of economics. Economics studies the efficient allocation of resources. Efficient here means if this measure of efficiency, total surplus, if it's maximized. If we make total surplus the biggest it can be, we say that this allocation of resources is efficient. Now let me be clear. While studying efficiency is very central to economics, it's of course not the only measure that matters for how our society allocates resources. For example, fairness might be a concern, but it's not something that we have a geometric measure for. Efficiency is the one that we spend a lot of time studying and where economics makes most of its contributions. So let's look at the sort of market we've talked about so far. Competitive markets in equilibrium. Here are the supply and demand curves of the shoes again. If we put them together, we'll see that this shoe market has an equilibrium outcome of 15 pairs of shoes being sold at $30 each. And this now leads to a question central to economics. So this outcome, if we just let the market find its equilibrium, is it efficient? Well, let's have a look. Consumers benefit equal to the area below the demand curve, above the price. Producers above the supply curve, below the price. And as we've just learned, total surplus is the sum of those two. The big triangle now highlighted in red. The question of efficiency is the following. Is that triangle as big as possible? Or could we interfere with this market in some fashion and generate even more total surplus? Let me take you through the explanation of what's so attractive about this equilibrium outcome. And let's do this step by step. So let's focus on our buyers first. If all you're concerned about is total surplus, you can think of that as buyer value minus seller cost. Buyer value, as we learned today, willingness to pay, that is the height of the demand curve. So this demand curve, it represents for each of the shoes what that shoe would be worth to that consumer. For example, if I want to answer the question, what is the worth of shoe number 5? I can look at the demand curve and see that the consumer who buys shoe number 5 values it at $50. Now look at this demand curve. In the equilibrium, not everybody who wants a shoe actually ends up with a shoe. Only 15 pairs of shoes are sold. But who buys those shoes is not random. Willingness to pay means the people whose willingness to pay is greater than or equal to the price buy the shoe. I've indicated those 15 individuals with a red brace on the demand curve. Now, look at the people who do not buy the shoes. Anybody who's not willing to pay $30. That means that the value to those people who buy the shoes is higher than the value of those people who do not buy the shoes. If our objective is to maximize the difference between buyer value and seller cost, this is a great start because we've identified the highest buyer values. Now let's look at this from the perspective of the sellers. Their cost is represented by the supply curve. For example, if I asked you, what does it cost to manufacture shoe number 20? You could look at the supply curve, its height, and say that shoe number 20 has a production cost of $35. Now this supply curve represents all the shoes our society could produce, but not all of them will be produced. Our rule was sellers produce those shoes whose cost is equal to or less than the price of the product, here indicated by a red brace. The shoes who've got a cost above $30 will not be produced in a market. So what's that mean? Left to its own devices, a market will produce those units whose cost is low, lower than or equal to the price, and will not produce those units whose cost is high. If our objective is to maximize total surplus, the difference between buyer value and seller cost, that's a good start. So at this point, we've already established that markets allocate resources from low cost of production to high value. A good start. But there's one more thing we have to establish. Is the market producing the right number of shoes? Is it producing all the shoes that generate a positive number for total surplus and no shoes that would generate negative numbers? Well, let's have a look. Let's start with a very specific shoe. Let's talk about shoe number 20. Shoe number 20 has a production cost of $35, the height of the supply curve at quantity 20. What would be the value of shoe number 20 to the person who receives it? Well, let's look at the height of the demand curve. That's a lower number. The value of this shoe is only $20. If we were to produce this shoe, it would lower total surplus. It would give us $20 on the value side, but add $35 on the cost side. Total surplus would fall if we were to produce this shoe. From a total surplus standpoint, we should not produce shoe number 20. We should not produce any shoe where the supply curve has a height exceeding the height of the demand curve. So in other words, if we are currently producing 20 shoes, it's time to cut back on production. This will actually raise total surplus. So look at what the market does. The market produces 15 shoes. It automatically doesn't produce the shoes that will produce negative surplus. Because you can't make that trade. Nobody's willing to spend $35 producing a shoe that buyers are only willing to spend $20 buying. There would be no way to make a mutually beneficial trade. Now let's look at the other side of the equilibrium. Let's have a look at shoe number 10 for starters. Shoe number 10 has a lower production cost, $25. Let's look at its value. Tracing up to the demand curve, we find that it has a buyer value of $40. So what that means is that shoe number 10, if produced, contributes to the total surplus of our market. We are producing something that has a value of 40 at a cost of 25. Total surplus will increase by $15 if this shoe is produced. So in other words, shoe number 10 should be produced. In fact, every shoe should be produced where the value, as determined by the demand curve, exceeds the cost, as determined by the supply curve. If we are currently producing 10 shoes, it's time to increase production to raise total surplus. And what's neat about the market? Well, all those shoes are produced by the market. The market automatically produces the 15 pairs of shoes that contribute to our total surplus. So let's put all of this together. A competitive market reaching its equilibrium has desirable properties from an efficiency standpoint. It produces all the shoes that contribute to total surplus, none of the shoes that would subtract from total surplus. It produces the shoes that have the lowest cost and allocates it to the buyers who have the highest value. If efficiency is our goal, the market outcome achieves this efficiency. So we would say it is efficient. Total surplus is maximized. Now, please remember, at this point, we're discussing competitive markets, and they are great at maximizing total surplus. Of course, later on, we're also going to talk about situations where markets, if you leave them alone, fail, meaning they do not reach efficiency. Common examples include if there are externalities present, or if, for example, a monopoly exists. We will discuss this in greater detail. But, as we often like to say in economics, when it comes to a competitive market that doesn't have these sources of market failure, it's often best to let it be, or laissez-faire. That concludes our first discussion about consumers, producers, and the efficiency of markets.